Good evening, everyone. Smriti, good evening. Very hurry, very started class here. Just came, jumped and came. Yes. So today it is 10th topic also, and it is topic for seated class also. So this is magnetism I'm going to teach today. Magnetism class I'm starting. So now look here. We need to understand about magnetism. Ruchi, I'm fine, thank you. So now listen, I'm going to start the session, please. Yes, in the starting of the session, yes, Ruchi, I was waiting for you only. Yes, nice, it was good. Now let's see. Now look at in the magnetism section, what and all we need to study first to check. See, CTET may whenever they will be asking questions, they will be asking questions related to many factors. So one factor will be magnetism chapter also. So here from magnetism is exactly that chapter from where you can easily grip and solve the questions, because science means they can be asking questions from any one of the sectors. Okay. So now here, when we are talking about magnetism, just check this one out. What and all things you have to first understand. See, about magnetism specifically, I am telling you what and all things is there. So you know that magnetism is exactly magnet. So what is a magnet? A magnet is a substance that is exactly a specific type of substance. It is exactly called as magnet, and it will be exactly attracting small pieces of ferromagnetic substances, means those substances which are exactly been made to get attracted by magnet. Like we know that we can attract any iron objects because they are ferromagnetic, and they are easily getting that they are easily getting attracted towards it. So that is called as ferromagnetic substances. Okay. So now we are going to talk about substance which attract small pieces of iron and is exactly having two. It is pointing two direction, north and south direction. When substance freely, yes. Okay. So this is what. So here this is known as magnet. It is exactly called as what? Understood. So this is exactly called as magnet. Okay. So magnet will be exactly having two poles. One pole will be considered as north pole, and another pole will be considered as south pole. Understood. So they will be pointing towards north and south. So this is exactly considered as magnet. Now for magnet, we must know about one point. That one point is, so this is exactly the example of bar magnet. So bar magnet will have one north pole and another one will be considered as south pole. So bar magnet will have one north pole and another pole will be considered as south pole. So when we will be talking about north pole, the north pole will attract south pole. Okay. So that means that's what always we say now, the opposite attracts. So here opposite is attracting. So here north is exactly going to attract south. Okay. This is exactly about the poles. So north is exactly attracting south. but north will repel north. So if north will be there, so it will exactly get attracted towards south. Understood? But when we will be talking about north and north, so definitely north will repel and south will repel, but north south will attract. Okay. So there are certain properties of magnet we will try to know. So natural magnets are irregular in shape. This is most important thing, because simple concepts they're asking question. So this is a very simple concept that okay, what about irregular magnet? That is a bar magnet, and bar magnet have a regular shape. Okay, so it will be either in the shape of a rectangle. You will be seeing bar magnet. So definitely bar magnet shape is rectangular in shape. So it is having a regular shape. But natural magnet, what we are getting, it is not having a proper shape. It is irregular in shape. Okay. So now, moreover, they are weak magnets. Yes, because they cannot be inclining. The magnetic lines of forces that is coming is not so strong. Now, an iron bar magnet can be made magnet by rubbing it with a natural magnet. Such a magnet is known as man-made magnet or artificial magnet. So usually these type of bar magnets are not called as natural magnet. These type of magnets are considered as man-made magnets or artificial magnets. So these type of magnets are considered as man-made magnets or artificial magnet. Man-made magnets or artificial magnets. So now we are going to understand some of the most important properties of these magnets. Now look here. So I'll be explaining about some of the properties of this magnet. So let's talk about these properties. Now first you understand this. This is exactly a bar magnet. The bar magnet will have north pole and south pole. Understood. So now the magnetic lines of force will be generated. The magnetic lines of force will be generated. From where the magnetic lines of force will be generated? The magnetic lines of force will be generated from north pole and it will go towards south. So these are called as magnetic lines of forces. So these are considered as what? Magnetic lines of. It is going to be over. Just give me 1 minute. Is it over now? Yeah, I saw internet issue. I'm visible. No, I'm visible. Internet issue over. Ruchi, can you see me? Now is it okay? Yes, fine. Yes, some internet issue was there. Now it is okay. So the magnetic lines of forces always comes out from North Pole and it goes towards South Pole. But one simple question is coming that these lines of forces will make exactly like come like this. So we will draw like this. But there are certain important points about these magnetic lines of forces. Okay. The first important point about these magnetic lines of forces are these lines of forces are continuous closed curves. Point one, closed curves. Closed curves. They are making these lines of forces are closed curve. Then your first question will be, hey, where is the closed curve? It is exactly coming from, yeah, mic I'm using, but some problem is there. I don't know. So now look here, wait, I'll switch off that. Then mic problem will not. I hope now it is not going to create any problem. Please now look here. Focus and work. So magnetic lines of forces are closed curve. Closed curve means what? They will be exactly coming from north pole towards south pole, and inside it will be exactly running parallel and it will join. Okay. So inside it is going from south to north and outside it is going from north to south. I hope you might have understood which is it okay. Inside it is going from north to south. Inside it is going from north to south and outside it is inside it is going from south to north and outside it is going from north to south. This is exactly about the magnetic lines of forces. This is about magnetic lines of forces. Now magnetic lines of forces inside they will run parallel. They will run parallel. inside the magnetic lines of forces will be parallel to each other, and outside it is making closed curves. Outside it is making closed curves, but inside it is making parallel. Understood? So this is about magnetic lines of force. Now where we can get the magnetic lines of force, more strength of the magnet, where can be the strength of the magnet more? The strength of the magnet will be more near the poles. Okay, the third point is the strength of the magnet will be more near the poles. Near the poles, the strength of the magnet will be more. So if somebody will be asking you where the strength of the magnet will be, because the lines are exactly coming out in north pole direction and south pole direction. So definitely the strength of the magnet strength will be exactly near the poles. So you might be seeing this. So strength of the magnet is exactly maximum near the poles. The strength of the magnet is maximum where? Near the poles. This is one of the most important point. So if somebody will be asking you where the strength of the magnet is maximum, the strength of the magnet is maximum near the poles. This is one important point. Okay. So we learned three basic things. The magnet lines are exactly parallel. They are making closed curve. First point. Second, inside the magnet, the lines of the magnetic lines of forces are parallel to each other. Okay. Third point is near the poles, the magnetic field strength is high. The magnetic lines of force are exactly having magnetic field strength higher in near the pole areas. Okay, pole areas means north pole and south pole. Now the fourth point, the magnetic lines of force never intersect each other. Fourth point is the magnetic lines of forces are never intersecting each other. Understood? So magnetic lines of forces are never intersecting each other. Means these lines of forces you will be seeing, they will run parallelly in closed curve regions. They will run parallelly in closed curve regions, but they will never intersect each other. Okay. What is the reason they will never be intersecting each other? The answer is this is exactly one curve. Now this curve will have tangent point. Okay, so because magnetic lines of forces are direction specific, it will be exactly going from north pole towards south pole. So 100% it will orient the direction. So another lines of force, if they will intersect, if there another lines of force it will intersect, then its direction will go like this. So at that point, when two lines are exactly intersecting each other, the tangent drawn will intersect each other. And we know that the point of contact means any point in a circle will be able to draw only one tangent. But here it will be giving how many tangents? It will be giving two tangents. That is not at all possible, and that is not at all good also. That's not direction specific. So 100% the answer here is the magnetic lines of force will never intersect each other, because the point of intersection of magnetic lines of force, the point of intersection of magnetic lines of force will generate two tangents. So here you see one tangent is generated, and here you see another tangent is generated. So one tangent is generated in this direction, so that means what? One point of contact is there, and this point can have only one tangent drawn. But here two tangents are drawn, that is exactly violating the rule. So 100% the lines of forces will always be parallel. The lines of forces will never intersect each other. I hope you might have understood this point. So this is exactly one point. This is exactly never pull. So I hope everybody understood this. So now we are going to go to the next point. What happened? Okay, so this is exactly one point we have discussed. So we talked about natural magnet and we talked about bar magnet. In bar magnet, we came to know certain properties. Okay. Now next one. So natural magnets are irregular, and we know that by rubbing a natural magnet to a bar magnet means we can magnetize any one of the steel object. Okay. So because see that will be what you call continuous to and fro motion of a magnet on a non-magnetic substance will convert it as a magnet. So if I will take any steel object, understood? Okay, so if I will take it as a steel object, so if I'm taking a steel object and I'll try to what you call, or an iron object, and I'll try to keep on moving the magnet same position, means it will magnetize that object. Okay, now it can get converted into permanent magnet, or it can get converted into soft magnets, temporary magnet. Like if I will take soft iron, then it will get converted into temporary magnet. But if I will be converting, if I wish to convert it into permanent magnet, means if I will be exactly putting it, I will be exactly putting it again and again. So please check this one out. I hope, Richie, did you understood this part? Did you understood this part? So permanent magnet and temporary magnet, did you understood this? So when a magnet will be permanent and when a magnet will be temporary? Yes, yes. So that's what is about permanent magnet and temporary magnet. So I hope you might have understood about permanent magnet and temporary magnet. Okay. So now we will go for the next one. Now please check. This is exactly U-shaped magnet. Electromagnet, U-shaped magnet. If somebody will be asking you about. So now bar magnets and U-shaped magnets are common examples of artificial magnet. So these U-shaped magnets are also artificial magnets. These U-shaped magnets are also artificial magnets. Now we are going to talk about magnetic and non-magnetic substances. So this is again another point to be noted: magnetic and non-magnetic substances. So if somebody will say a substance that are attracted by magnet are called magnetic substances, correct? Means those substances which can get attracted. But here now you see one thing: the north pole and south pole will be there. Now the lines of forces will come like this. The magnetic field lines or magnetic field lines are also called as magnetic lines of forces. Remember this word. Magnetic field lines are also called as magnetic lines of forces. They will also be coming in U shape also. It will be coming from north pole and it will go towards south pole. In U shape also it will be coming from north pole and south pole. It is exactly considered as more stronger than bar magnet, because the magnetic field lines are very cozy near one junction only. So 100% it is more stronger than bar magnet. Okay. Now here, magnetic lines of forces, they are connected. So those substances which are exactly getting attracted by magnet is called as what you call, they are called as magnetic substances. Means they are magnetic substances. Like examples of magnetic substances are iron, nickel, steel, and cobalt. These are exactly ferromagnetic. Ferromagnetic means those substances which can get attracted by magnet are also. And in class 11th and 12th, you might have understood ferromagnetism and paramagnetism. Understood? So that is different things. We are not going to talk too much about them. That they will not be asking. So here you just remember that magnetic substances are those which can get attracted by magnet. Like example, iron, nickel, steel, and cobalt. Okay. But there are certain substances which are not attracted by magnet. They are called as non-magnetic substances. Example, wood, stone, plastic, aluminium, and copper. They are considered as non-magnetic substances. Okay. Now we will go for properties of magnet. Just now I discussed some of the properties of magnet. So definitely we know that its property is called attractive property. So the magnet can attract magnetic substances. Yes, we know that a magnet is attracting magnetic substances. So this is exactly one of the property. Direction property, a freely suspended magnet always rests pointing in the north-south direction. This property of magnet is called as directive property. So I'm going to discuss about this property. So if I will talk about a magnet, so I suspended a magnet freely. Okay. So what I'm doing is I'm suspending a magnet. This is your earth. Okay, so whenever we talk about Earth, you understand one thing here, that if I suspended a magnet freely, that then what is happening? The magnet will point towards north and south direction. Did you saw this one? The magnet will be exactly pointing towards north. So always the bar magnet north will be pointing towards geographical north. It is pointing towards geographical north, and south will be pointing towards geographical south. But you know what? The angle will be slightly tilted. It will not align with geographical north. It will make some angle. And you know what? Because the earth itself is having, the earth itself serves as a magnet, because inside the core of earth, the magnetic magmas are there. See, the molten magmas are present. In the core of the earth, the magnetic substances like iron, molten iron are there. So they also generate a magnetic pole. Okay, so this is exactly the bar magnet. Okay, but earth magnet with direction is not this. Earth magnet north is down and south is up. Earth magnet means earth itself is acting as a natural magnet. Okay, so earth magnet north is down and south is up. Got it. So earth is exactly serving as a magnet, and its north is down and south is up. And our magnet, when you will freely suspend, it will point towards north here and south here. So that is the difference. So our magnet will be pointing towards geographical north. Understood? And earth is having earth magnet is south up and north down, and because of this, attractive pull will generate like this, and north and south will attract each other. Understood? But always the geographical north and this one will always make, so earth south and north and geographical north will make some angle. Understood? That angle may vary. See, sometimes the angle will be coming as 11 degrees, 11.7 degrees, 10.8 degrees. So every after, so that means what? Earth will generate magnetic lines of forces. That means what about earth magnets? So earth magnetic lines of forces will be generated like this. Okay, and because of this, whatever cosmic waves or radio waves are coming, earth is exactly throwing it out. So because of this magnetic pull, it is never entering inside the earth. That is one of the most important thing. The next important point to be noted here is that this angle between geographical north and this one will shift. Understood? So every after 100 years or 200 years, it's totally dependent upon the time. That is called as lap. Okay, lap. In space we will call it as lap. So what it is exactly coming like, ki the earth is exactly making magnetic field. Okay, now this magnetic field saves us from the cosmic waves, the radio waves. Okay, because whenever any cosmic waves or radio waves try to enter inside this region, the magnetic lines of force are pushing it away. Okay, but you know what? Every after 100 years, the angle shifts, because there is a slight tilt, there is a slight shift in that region. So when there will be slight shift, at that time the magnetic lines of force will change its direction. Change its direction means slightly for some time. If it is off guarded, means the lines will go. The moment the lines will go, the cosmic waves will enter, and that time only it will be poisonous. It will be hazardous for what you called the earth. Otherwise, its lines of forces will be nicely protecting the earth from cosmic waves. Is it clear? Ruchi, is it clear? I am in short. I am explaining the magnetism. Every part of magnetism I am explaining in very very short. Is it clear, Ruchi? Is it clear to you that this is exactly the properties of magnet, and in that earth magnet I have also discussed. Hmm? So this is exactly, so directive property. So this is what I am always telling, that the a freely suspended magnet will always point towards north and south. Okay, but the geographical north is exactly up, but magnet, our earth magnet, south is up. Our earth magnet, the natural magnet of earth, is exactly south up and north down. You remember this because they will ask this question. They will ask this question, and this is exactly one of the most important part. Attraction and repulsion property. Yes, same pole repel, opposite pole attract. This is another property. Okay, next is magnetic compass. So definitely a freely suspended magnet will be exactly acting as a magnetic compass. What they will do, they make us of directive property of magnet. So magnetic compass are of great use of travelers. Okay, but always, because it will always point towards geographical north. So since it will always points towards geographical north, it's definitely will be very very helpful for us. Okay, now magnetic compass are of great use of travelers and negotiators as they tell them about the direction in which they are traveling. So that's good. So now we are going to talk about temporary magnet and permanent magnet. So how can we make a temporary magnet and how can we make a permanent magnet? Okay. So temporary magnet. Electromagnets are temporary magnet. Bar magnets are permanent magnet. Means the bar magnet, what you are buying from market, they are permanent magnet. Okay. Now, how can we make that? So, a magnetic substance, if we will keep on rubbing in one specific direction, then one substance will get magnetized. Understood? Then, how much years it will get magnet, how much month or how much days it will be magnet, it depends upon the property of the substance. That's the intrinsic property of the substance, means how many months that impact of magnet. Because see, if I am exactly prone to magnet, means I am getting attracted towards magnet, and you try to magnetize me, so 100% I will get magnetized, and I will act as a magnet. I will itself behave as a magnet. Okay. So now you need to understand this. So magnetic property for a short period of time, if it will be there, it is called as temporary magnet. If the magnetic property will remain for a longer period of time, it will be considered as permanent magnet. Okay. And that's what I have also explained about permanent magnet and temporary magnet. So we need to understand that what is the difference between permanent magnet and temporary magnet. So what is the difference between permanent magnet and temporary magnet? So now look here, bar magnet. We are going to talk about bar magnet. So bar magnet is permanent magnet. Electromagnet is temporary magnet. Okay. Bar magnet is having north and south pole. Its strength can change. See, the magnetic effect of bar magnet is fixed. We cannot change it. But we can reduce the magnetic effect of electromagnet. We can reduce or increase. So that means what? We can increase or decrease the magnetic effect of electromagnet. But here this is permanent and this is temporary. Understood? So this is called as permanent magnet. This is exactly temporary. So the magnetic lines of forces of electromagnet can be increased or decreased, but the magnetic lines of forces of bar magnet is fixed. Understood? So here this is the temporary magnet, this is the permanent magnet, and this is considered as a temporary magnet. Is it clear, Ruchi, till here? Can you say? So magnetism, one shot only I am teaching so that it will become very easy for you to remember. I hope, Ruchi, is it easy for you now to understand? Electromagnets are temporary, this is permanent, but this magnet you cannot increase or decrease the magnetic effect. But here you can increase or decrease. Understood? The magnetic lines of forces are fixed here, and magnetic lines of forces you can change. This is exactly, see, when you will allow current to pass through it. So definitely there is a connection between current and there is a connection between magnetic effect. Okay. So when I will allow current to pass through anything, definitely perpendicular to that magnetic field will be generated. Understood? So that here comes the concept of solenoid. Okay. The solenoids are the round coiling turns. These are exactly solenoid. Now this solenoid, if I will keep magnet inside outside means it will definitely, if I will keep some rod inside it and allow current to what you call pass through it, then it will act like a magnet. It will act like a magnet. Understood? The inside soft iron bar. Inside we will put soft iron bar and we will allow current to pass through it. The moment we will allow current to pass through it, it will act as a, this part will be act as a north pole and south pole. North pole and south pole. So when it will act as a north pole and south pole, something good will be happening. What is something good? So here if this is north pole and this is south pole, so definitely this will be exactly, if you want to increase the magnetic effect, then you have to increase either the current or you have to increase the number of turnings. So if you increase the number of turning, this will become a stronger magnet, or if you will increase the amount of current passing through it will become a strong magnet. Okay. But here bar magnet strength is fixed, it cannot be changed, but electromagnet strength cannot be fixed. We can increase it or we can decrease it. I hope everybody understood. So this is the one of the most important parts. So bar magnet and electromagnet, permanent magnet, temporary magnet. We can increase the magnetic effect, we cannot increase the magnetic effect. We can decrease the magnetic effect also. So for cataract operation and all, electromagnets are used because they are used for cutting purpose also. Sharp cutting means electromagnets can be used. I hope you might have understood this one. In very short, I am explaining the most important topic, magnetism. So I am trying to explain you in the most simplest way. Okay. So you need to understand that magnets are used to separate iron and steel. So in you know what in metal extractions also we can use magnet. You might have seen big magnets are there, and that big magnets, they can pull magnetic substances. So that's again one some of the properties of magnet. I hope you might have understood this one. So now look here. So data, sound and images are stored on specific surface coated with magnetic material in computer, hard disks, floppies, and audios and video tapes. So they are exactly talking about the uses of magnet. Definitely motor, generator, loudspeaker have powerful magnet inside it. Okay, that's we'll discuss about it. Next, scrapyard also they will be having one round magnet, and they will. Hi Sharon, how are you? Now, information is shorted in magnetic strips in credit card, and ATM cards are also airline tickets. So, whatever magnetic strips are there, that is exactly also having magnet in that. In all the devices, in all the electronic devices, you will definitely be experiencing magnet with it. Okay. So, magnetic field, the magnetic field generation, I've already explained you about it. How are you, Sharon? You deleted message. The space or region around a magnet with which it influences can be felt by another magnet is called as magnetic lines of forces. Okay, so the magnetic line is exactly represented by a series of lines. That's already I have explained you. So these are the magnetic lines of forces. The magnetic lines of forces will be coming from north direction. It will go towards south direction. The magnetic lines of forces will start from north direction and will head towards south direction. Okay, so the magnetic field lines are closed continuous curve. I explained it. Next point, the tangent at any point on the magnetic lines of force will give the direction of the field. That's a very important point. Next point, no two magnetic field lines can intersect each other. For that also, I gave you an explanation why they will not intersect, because they will give you two lines, and these two lines intersecting means one point. See, for drawing a tangent, you need only one point, and when two magnetic lines will intersect, it will be one point, and that point. Thank you so much, Beta. God bless you. You're also doing very good in life. I came to know about you. Yeah, you're doing research right now, no? Nice to see you, Beta. Nice to see your dedication also. So you're definitely encouraging everyone. That's also very high level encouragement, yeah. Bless you, Beta. Super. Any paper published? Message me after class, huh? Yes, I'll talk to you. How is your life going on? What and all you are doing? We'll discuss about it. So now look here. So magnetic field lines are crowded in the region of strong. So I told you, now near the poles. Super. Indexing will done means inform me. Yeah? So now look here. So we will talk. I'll message you, Charan. Bless you, beta. Grow like a tree. Yes. My paper are also under that only publication. I'm also waiting. So now look here. Magnetic field lines are crowded in region of storm. So definitely when you will be talking about poles, the North Pole and South Pole, because near the poles, the magnetic field strength will be more. Thank you, beta. All the best to you too also. So definitely. So on the other hand, magnetic field lines are far from each other in a region of weak magnetic field. Yes. So whenever region of you see you know that the outer region, Ruchi, that region, it is exactly what there the magnetic field lines are very away. So definitely the magnetic field lines are weaker. Handling magnet. Magnet lose their properties if they are heated, hammered, or dropped from some height. So that's what is exactly the weakness of magnet. So if I will be hammering a magnet, magnet will lose its property. If I will heat a magnet, magnet will lose its property. If I will drop a magnet from certain height, it will lose its magnetic property. So these are some things which is exactly going to tell that the magnet is losing its property because of all these factors. Ruchi, I hope you might have understood this one. I hope you might have understood Ruchi till here. Now, bar magnet are always stored in pair with their unlike poles of same side. So definitely we are never leaving a bar magnet alone. We'll always keep a bar magnet with another bar magnet, but we will be keeping opposite so that they will attract each other. Okay. They must be separated piece of wood by separated by a piece of wood. Two bar of soft iron called the magnetic keepers are kept across their ends. Yes, otherwise they will attract each other and lose their magnetic property. Floppy disk, CD, computer, credit card, television sets, and audio and video cassettes are kept away from magnets as they get damaged. Yes, this is demagnetized. The magnets can get demagnetized. So what we are doing is we are keeping away magnet from all these things. That's also one of the most important property. But you read this part. This is important. Bar magnet are always stored in pair. They may ask this question: how can we store a bar magnet? Always in pair with their unlike poles, means north with south and south with north. Otherwise, north and north will fight. Okay, but they must be separated by a piece of wood so that the magnetic lines of force will nicely go and can keep its magnetic property intact. Okay. Two bar of soft iron called magnet keepers are kept across their ends, yes, so that they will not lose its magnetic property. So that's one of the most important thing we must remember. Now look here, there are certain rules and regulation for magnet. So definitely, William Gilbert suggested that Earth itself behaves like a huge magnet. This magnet is so oriented that its south pole towards geographical north. That's what I already explained, Ruchi. That Earth geographical north and south pole of Earth will be exactly merged together, and they are making what degree? Just see. The Earth behaves as a magnet dipole inclined at a small angle of 11.5 degree. I told you, the degree variations also I have discussed. So now, South Pole going geographical north. That's again an important fact. A freely suspended magnet always comes to rest as north-south. That is, Earth-south will exactly merge with geographical north. Okay. So when we draw field lines of bar magnet, we get neutral point where magnetic field due to magnet is neutralized by Earth magnetic field. Yes, that's exactly the most important point that you must remember. So a freely suspended magnet always comes to rest in north-south direction. A piece of soft iron buried in north-south direction inside the Earth acquires a magnetism. Yes, we can also magnetize them. Yeah. See, look here. This is exactly one of the most important property, Charan. It is one of the most important property. You might have you might have heard about one place where there is no magnet effects are there. I think in many of the examples they have talked about this. See, always the magnetic lines of forces like normal substances are there now. So these normal substances will not lose its magnetic property. If you are doing research means you will be understanding one point that the magnetic lines of forces are the intrinsic property of the material, and that is coming because of its factors like SPDF contents are there, the poles will be exactly generated there. So if you will go in depth, so magnetic properties of that particle temperature, yes, now that's important. That's very important. I'm going to discuss it. So a bit curious. Could you explain what is Curie point? So I think at that point and how a metal instantaneous loses or gains magnetic property at a particular temperature. Not about a particular temperature. If you will heat it, to that critical point, yes, the critical point will become the particular temperature. The magnetic effect will be exactly going in that particular temperature, because change of state will be there, na Charan? Because of that also it is possible. Okay, and another important point is, yes, in on an earth there is exactly, if you are talking about Curie point, exactly I don't know, but there is one point on earth where the magnetic effect will not be there. Miss, you might have seen that exactly, that 0 degree some line is there, I think. I Are you talking about that Curie, that point? I don't remember the name. Is it that Curie point you are talking about? Is that Curie point you are talking about, beta? Is that Curie point you are talking about? You need to answer me this question. Is that Curie point? Or you are talking about the point at which the critical point, because one critical point will be there at that particular moment. Critical point you mentioned, yes, the critical point, yes, it can be a critical point, beta. Yes, it is exactly permanently, it is going to lose its magnetic property. It is going to lose its magnetic property permanently, Sharon. So whenever this will be happening, it will lose its magnetic property permanently. Yes, Himanshu, he has asked one question. You just answered this question. Okay, like iron will be there. Different type of metals will be losing its magnetic property. 1 minute, I'm getting a call. Yes, yes, yes. Yes, so you need to understand that all the iron materials are ferromagnetic in nature. But one thing is there that SPDF contents are there now. Just 1 minute. Hello? हाँ ना 1 minute I'm coming. So definitely we are going to talk about. So Curie point means definitely they will be what you call. I think it is connected to some energy or heating that particles, the loops. Because I know now that ferromagnetic substances means SPDF, some D block elements, the D block junctions will be there and they will be just shifting that. So definitely the magnetic domains will be permanently getting damaged. So they will just. Okay, look, I'm keeping it till here. That's what I think is Curie point. I need to read about it. I don't know that much point about Curie point, but yes, I know it is a critical temperature at which the magnet will directly getting losing its magnetic property. Okay. Okay, Ruchi, I'm going to keep it till here. After that, I'm going to start with the pedagogy. Huh?